He's asking a question in your question/statement. I differentiate between model and data drift on a high level. Do you think that data drift or do you think that data drift monitoring is still necessary when you get ground truth faster than model decays? Because in my opinion, data drift often is monitored just to estimate the model drift when ground truth is not available.
That's an excellent question. If you have almost instant feedback to a model prediction to get you a validated quality metric associated with the model, you don't have to have all of this intense monitoring of each of the features. It's important to understand the shape and nature of that data just in general, because depending on the model implementation that you're using, that nature of that data, a lot of people are using tree-based algorithms. I see XGBoost everywhere these days. But if you're using some of these gradient boosted implementations, if the distribution changes on a particular feature, it's going to change the way that the entropy calculation is happening because of where the boundary separation is going to occur on continuous variables. If the actual ordinal count of when you have a cardinality change in a categorical feature within an index position that's going into a model like that, that's going to change how the split occurs and what the calculations are. So I always monitor the distributions of things. Even sometimes it's just simple. I'm monitoring the mean of each feature and the standard deviation, and then calculating the skew and saying how stable is that over time. If I'm getting a fast response to a target and I can know within minutes of a prediction being made how good the model is, then I'm basing retraining and alerting on that quick feedback loop that I'm getting, but I'm doing model re-architecture and refactoring based on the nature of the feature data coming in. Because sometimes a retraining event is not going to fix anything. It could actually make your model way worse. Sometimes you need to get all the information associated with the features coming in and the predictions to say, hey, it's time to make version 2.0 of this model. Like, we need a new feature vector. We need to rethink how we're doing this. We might need a completely different algorithm because the state and nature of this no longer supports our data. So yeah, excellent question. Hopefully I answered it fairly well.